Okay, this video is going to be super short because we're going to do a project tomorrow where we'll do most of the learning. But I want to introduce four special segments in triangles to you. The first of those being mid-segments. Now, mid-segment is exactly what the name implies. It's the segment in the middle of a triangle. Now, basically, and I'm using three different triangles to show it to you in three different ways. But if you have a midpoint of this side and a midpoint of that side, then it connects those two midpoints. Okay, now we can turn the triangle and we can have the same mid-segment along this way. So over here, the midpoint, I'm just estimating this is about in the middle, is it's going to connect the two midpoints. Okay, and then lastly we have a mid-segment over here. So there's three mid-segments in each triangle. If we look at over here, it's the same idea, even though we have a right triangle. Is this mid-segment and that mid-segment, or that those segments connecting, is only one mid-segment, connecting the two midpoints. But either way we turn it, it's going to be the same. Okay, and then if we come here, three mid-segments in that triangle, and you know, boom, boom, boom. Okay, three mid-segments in each triangle. Okay, an angle bisector, you're familiar with that already. You know what an angle bisector. Bisector means to cut in half. Write that down if you don't already know it. So it's going to cut the angles in half. So in a triangle, basically just what we mean is that it's going to take this angle and it's just going to cut it exactly in half and do something like that. You know, again, because it's a triangle, tri meaning three, we have three of everything. We have an angle bisector come over here, and it cuts that angle in half. And then lastly, this comes through and cuts that one in half. And we get some pretty cool designs going on inside these triangles. And either way, and I'm just estimating where it cuts it in half. We should probably have out a protractor to get it exact. But I'm just estimating. I'm just going through and cutting each angle in half. Okay, and no matter what the triangle looks like, it's the same basic idea. We're cutting each angle exactly in half. Right, moving on, a perpendicular bisector, perpendicular meaning it intersects at a right angle, and bisector again meaning to cut in half. So essentially, it's going to be a segment that's perpendicular and it bisects. It does both of those things. So if we look here, I mean the midpoint is going to be about here. So to bisect it, it's going to have to come through right here. And if it's perpendicular, it just means it's going to be straight up and down. Okay, bisect, so that is the same as that. And we got the same thing going on over here. Is if it bisects this segment, it's going to come right through the middle, and it's going to be straight up and down. Okay, and that's all that it is. And if we're coming over here, right in the middle, and coming up straight up and down. It's going to look that same way in each different triangle. We're going to go right through the middle, straight up and down. Now notice it doesn't go through the other vertex. It can't. If it did, it wouldn't be at a 90-degree angle. But each side, it's going right through the middle and straight up and down. Okay? And you get the hang of it. You go through and do that with each one of these. Coming right here is about the middle. Coming up straight up and down. And then lastly, we have an altitude, and an altitude is a fancy name for height. If you've ever been in an airplane, they say we're now flying at an altitude of whatever amount of feet. I mean, that's how high we are. And this is probably the most important segment in these triangles. An altitude is just the height. The height being from the vertex down to the base making a right angle. So notice that perpendicular bisectors make right angles, but they don't go through the vertex, and they have to go through the middle. This is obviously not going exactly down the middle. It doesn't matter. This is basically how high this vertex is, straight up and down. Okay, and we have 3 of each. If we came over here, the height would be from here straight down to make a 90-degree angle. And then lastly, from this side, from here straight down, making a right angle. Okay, now you got a couple different things going on in these 2 triangles. First of all, if you came from here and went straight down and made a right angle, you'd be here. This is already the height. Okay, if we turn it, now that doesn't hold true for every side. Coming from here, we can come straight down. There's the height this way. And then if we flip it this way, coming from here straight down again, this is the height of the triangle that way. We want to measure how tall this triangle is. We'd start here and measure down. That's the height of it, the altitude of it. Okay, now looking at this last one, here straight down, that's the height. If we do this way, this is interesting because if we come here and we go straight down, the height is actually outside of the triangle, and that's okay. The height of this triangle would be here, straight down. And the same thing goes on the other side, is if we go from this vertex, and if we go from here straight down, again we get the height being outside the triangle. Okay, that's all for this lesson. I know that was pretty fast, but just make sure tomorrow as we do the project that you know what each of these segments are. Okay, any questions you have, write them down. See you tomorrow.